What's up everyone, this is Ryan here and we are on episode 15 of my Android developer live Q&A. So let's get started here. So first things first, I don't have any major announcements for this episode. I was hoping to have my room sample ready by earlier this week, but it just kind of turned into somewhat of an unfortunate week, which I won't go into all that much, but one kind of amusing thing that I kind of ran into, and a big reason why my room sample isn't ready yet, is I've been doing a lot of research and reading into model view model, which is basically the architecture style which the Android team has pretty much touted as their de facto recommended style for architecting applications. And I'm going to reserve my judgment a little bit more on model view model, but one thing I've noticed, and this does tend to be the case with a lot of software architectures unfortunately, is that what people define as model view model and which pieces, which classes are actually necessary to have it function properly is something which varies, from what I've seen, pretty much from developer to developer. That's one thing why I like Model View Presenter, is that I find it pretty unambiguous. But yeah, in any case, that's a big reason. Like, I've been really doing a ton of research into Model View model, and there's a couple specific things which, well, if you're curious, I'll get into it later and just kind of do a discussion piece on it. You can ask me, but anyways, the project is mostly written. It's just kind of some finalization stuff with the view model and repository layer and stuff like that I'm gonna work on. But I didn't want to rush through it, and because I don't like to rush through things at all. Anyways, so not really any announcements. One thing I'd like to jump into is let's see here. So I just wanted to thank my patrons. So I'm up to, I believe, $86 a month, which I'm super excited about. And I would just like to thank Christopher Sturm, Bassam Halal, Mr. Bidwell, Tony Jones Jr., Elad Stavi, Trevor Halvorsen, Nanotech, Sushil Chanda, and Shadow for your very kind, generous support. I really do appreciate that. So what we'll do now, let's have a quick look at the stream, and we got a bunch of people. What's up, everyone? What up? Got Daryl Bitsy, Mr. Rainmaker, Sharoon, a whole bunch of people. So thank you for joining me. So what I'll do is, for the first couple minutes of the episode here, I'll be talking about the Liskov substitution principle. So let's hop right into that. So why won't you zoom in? There we go. Okay, so the Liskov substitution principle. So as I mentioned before, for starting on whatever episode 13, yep, that should be right. I've basically been going through each part of the SOLID acronym. And SOLID is, of course, a series of design principles. And what I wanted to do is, in 5 different episodes, just cover one of them per episode and kind of talk about them. And the principle that we'll be looking at today is the Liskov substitution principle. And this is, of course, now, the main thing about this is that these principles were developed by sort of a bunch of people working together, but in this particular principle was very well expounded by Barbara Liskov, and she designed it, or defined it very well in a series of papers and things of that nature, which I've actually started reading, not a behavioral notion of subtyping, but a different paper of Barbara Liskov. Unfortunately, it escapes me which one. And it's very interesting stuff that has to do with basically typing. So let's talk about the Liskov substitution principle. Now, the most important thing here is that unfortunately, a lot of the examples I found explaining the Liskov substitution principle in code are very contrived. They are scenarios where you kind of have to deliberately, I don't know, let's just kind of get into it, and maybe we'll kind of get to what I mean. But let's just start. So the definition, a more technical definition, and this is taken from a behavioral notion of subtyping, is so if for each object, and that's supposed to be O subscript 1, but this IDE doesn't handle subscripts. So for each object, and we'll just say object 1 of type S, there is an object O2 of type T, such that for all programs P defined in terms of T, the behavior of P is unchanged when O1 is substituted for O2, then S is a subtype of T. Now, if you're wondering what the hell that means, that's totally fine. You know, this unfortunately, this stuff does suffer from the jargon. So I'll just kind of decode this top definition, and then we'll get into a simpler definition. But basically what this is saying here is, so for each object of type, each object, so O1 of type S, you know, I'm never going to try and decode that. Let's basically what it's saying is, don't make subclasses which don't have the same functionality of the superclass if they're expected to be used interchangeably. Kind of what it's saying here is, like, you've got, let's say you've got objects S which are a subtype, a subclass of type T. Your application, which is what is meant by this program's P here thing, P should be able to use objects of type S and T interchangeably, if, like, assuming they are subtypes and assuming they will be used in such a manner. Don't make subclasses which don't have the same functionality of a superclass. In other words, if they're expected to be used interchangeably. Now, you might be kind of thinking, as I am, like, isn't that kind of like self-evident? I think it is to some degree. So I'm actually going to use some of the code from the previous lesson, which was on the open-closed principle. That was in the previous episode. But basically what we had here is I showed you that the wrong way to kind of handle changing requirements. So for example, in the example before, I was writing a class called exercise. And since there are all kinds of different types of exercises, like you could use a barbell, you could use a kettlebell, you could use your body weight. The wrong way to go about doing that is to create all this control logic here, and then so if barbell, blah, blah, blah. And a better way to handle that kind of variation, because I will very likely decide to add more kinds of exercises to this, is to use an abstract class or an interface, but in this case an abstract class works very well, some kind of abstraction. And so in that case, we create this abstract class exercise. And for each type of exercise, we create sort of a specialized subclass, a subtype. So for example, we've got body weight exercise. And it's important to note that if we're doing this properly, all of these subtypes must be able to have the same behavior. They must be able to act in the same place as sort of our abstraction. They should all of these different subtypes of exercise, so we've got body weight exercise and we've got dumbbell exercise. All of these should be able to, by the rest of the application that's working on these objects, it shouldn't even need to have code to differentiate which these are. It should be able to look at them all through this abstraction and work with them through the abstraction. So basically, just to wrap this up, this isn't a long explanation here, but when you're designing these classes, your goal, let's say we have a case, like for example an exercise, where we have things that are very similar, but they might change in little ways as time progresses, as I add more functionality to my application. If the part of my program which is using these objects knows these objects, or like literally, what's the word I'm looking for, references them through an interface, it does not need, that part of the program does not need code to differentiate them. So what does that mean? Basically what that means is it actually will reduce the amount of code we need to write and reduce the amount of logic in those objects because we're literally not writing this crap. Instead of this, all this stuff, we just have one print exercise data, which will return a string, and it'll satisfy the behavioral sort of contract there, but it's specialized based on what we need. So the contract here states we have a method called print exercise data, and it returns a string of exercise data. Now, the rest of my app doesn't need to know or care whether it's a body weight exercise that needs to do this sort of specialized code to create a well-formatted string, or maybe a dumbbell thing which needs to do other specialized sort of changes to that method. But everything gets treated the same by the rest of the program, and that is sort of my explanation of the Liskov substitution principle. Unfortunately, I did quite a bit of research on this, and it's just very hard to give good examples on it because you have to like really deliberately do things in a way that you have to set up contrived examples for it to some degree. Anyways, hopefully I've explained that somewhat well, and we will jump into viewer questions. So, what have we here? What's up, everyone? I am having a good day. So Mr. Rainmaker asks if I am considering learning Kotlin and making videos with it. Yes and yes. Basically, my big learning projects for now is first things first is I need to get that room sample and the full app tutorial for that. I guess it won't technically be a full app tutorial because we'll have a big starting point from the RecyclerView thing, but that is item number one. And then the next thing I'll be doing actually is getting into Kotlin and writing Kotlin, because I've got a couple of projects I want to work on which use Kotlin, and so it'll be an ideal sort of situation to deal ideal situation for me to learn it. Everything will be relevant to my actual projects, which is always a benefit. All right. So I don't really have any questions except something that's slightly off topic, but it's still something that is worth mentioning. You know what? So Mr. Clemo. Okay, well, I'm getting a couple questions on this. So the question. So this is slightly off topic from programming, but this is something I feel like talking about, and I don't actually have any other questions. So let's just have a quick look here. How to deal with procrastination? This is off topic from programming, but it is something very relevant to programmers. So no, to the people, I've got two people who've kind of asked this. So what I want to ask you before I proceed is, so what exactly are you having difficulty with? Are you having difficulty getting up on time? Are you having difficulty focusing? Are you having difficulty carving time out? Like, the more, to kind of quote Christopher Hitchens, this is such a big question that I either have to give you everything or nothing, and it's very difficult to give you everything. And so if you can be a little bit more specific, like what stage in your personal development are you at, and that'll help me out a little bit. But I can kind of riff on the general stuff. What I think I'll do, if you guys could just like try and give me more info, be a little bit more specific if you can. I'm going to answer a quick question about material design first, and then we'll come back to that question because it is a really good question. So let's go ahead and switch to the proper thing here. So Mr. Rainmaker, I always capitalize that, camel case. Mr. Rainmaker asks, and thanks for stopping by again. Mr. Rainmaker, if you would like, shoot me a message on the Bookface or YouTube's or something like that. And I'd be happy to add you to the WiseAss Developer Slack group if you would like. And but the question is, how do you understand material design? So, understand? I felt like I misspelled that for a moment. So I'm trying to think of how to sort of articulate my answer here. So how do I understand material design? So I'll start by just defining what material design is. And what material design is, the best definition for it, can be found at this website, which is material.io. So how do I understand it? And I guess maybe like how can we kind of apply it? How do I get to the part which I like to use? Design guidelines. Here we go. So when I go to this guidelines page, this is material.io/guidelines. The way that I know this is like not a very philosophical answer here, but the way that I understand and apply material design is literally by just reading through these guidelines. And most importantly, I'm a super visual person. So what I love to do is, let's say I'm implementing cards. I will go through these guidelines and I will look for a card that contains similar data to what I want to represent. And I will make, of course, slight creative changes to it, but I really just try and follow these specifications as best I can. So that's really that's like most of what I can tell you about material design. Now, I will also, as an addendum, add this. When it comes to user interfaces, if you're an individual Android developer, meaning you don't have a team of people to work with, to me, what is essential and most valuable with material design is that what it allows you to do is by changing very minute things, like worrying about little margins, making sure you've got a nice font, making sure pictures aren't screwed up, making sure different UI elements aren't squished together or in random places, making sure your user interface has like consistent sort of like keyline 16-dip margins, just all that kind of stuff. I don't really, what I love about that is in applying that, and the Android team makes it very easy to apply material design. In applying all that stuff, you can get from a very bland and ugly user interface to a simple and elegant user interface very quickly. So that's kind of all I can really tell you about material design. Obviously, like, I do put effort into my layouts, but to be perfectly honest, I am way more of a fan of the back end and the architecture stuff than of the front end stuff. Like, as someone who's an individual developer, I need to learn this, and I will, and I do put effort into it, but it's not my passion, and to be perfectly honest, I'm not the best person to ask about user interface. But yeah, that is my answer to that question. So let's just have a quick look. Okay. So guys, what I'm gonna do is, I do apologize. What I'll do is I'll answer the procrastination question at the very end of this episode, because I do have a couple of technical questions coming in, and that is of course the purpose of this episode, but I do want to get to that because I have some thoughts on it I can share with you. I am by no means an expert in dealing with procrastination, but compared to 99% of people on this planet, I am probably better than them. So anyways, let's see here. Hmm. So this is kind of a... Oh, okay. So the question here is, and this is by Martin S. And unfortunately, I'm not going to be able to give a great... I'll just give you kind of an opinion piece on this. But the question is... so Martin S. asks, what are your thoughts about Cordova and Xamarin technologies? So the main thing about this is I do not have a lot of experience in either of these things. I know that Xamarin is, if I'm not mistaken, a C++ framework for developing Android applications. And I don't actually know what Cordova is, but I'm assuming it is just some other, presumably something analogous to Xamarin. And then the question is kind of like, what are my thoughts on hybrid development and opinions on like will native development die soon and things of that nature? I can't really give a good answer on this because I haven't worked with those technologies, but there's a couple of things that I'd like to emphasize. So for starters, when it comes to Android, if you want to sort of be on the curve or ahead of the curve on it, you should really watch what the Android team does, where they take the development process. And again, I'm kind of, this is not something I'm really qualified to talk about, but I don't think that, for example, the Android operating system and Java and Kotlin are going to really go anywhere in, like, disappear within the next 5 years. However, this is totally an opinion piece, but this one night I was thinking about this, and what I was thinking about is I think eventually we are going to get to the point where our global internet will be, like, presumably if we get satellite internet everywhere and we just have instant access to really, really high bandwidth internet everywhere, in my opinion, at that point, it will largely make, whether I'm holding an Android phone or an iOS phone, I think the result of that will be that a lot of the code, a lot of the software architecture which would sit on this phone will just get moved to a central server in one language or one sort of stack of languages. And then things like these phones and Android and iOS, if I had to guess, I think these are going to mostly turn into views in the sense that they will really just shoot input to the cloud servers and then receive and display input. Like, obviously at the moment that's not really feasible because we can't expect devices to have a constant internet connection unless they're paying tons of money in data and all that stuff. However, the more I think about the fact that like, essentially the reason why that's an issue is simply because it's a bandwidth issue. The more I think about that, the more I kind of think, well, doesn't it, once we get to that point, wouldn't it make sense for this to basically just be like the front end of the application sits on here and then everything else sits up on a cloud server? So that's kind of my thoughts on that and where native development is going. I personally, within the next 2 years, want to dive into web development, and I don't think I'll ever like stop developing Android apps as a hobby, but I do think a lot about the fact that I think the fact that we have different mobile operating systems, I don't think it's going to make sense to learn and maintain all of these different mobile apps if eventually we just have internet so fast that I can offload everything to one sort of central server. So that's basically my answer there. Let's see, let's see. Yeah, so apologies if I mispronounce your name, but Beulah, you're saying you have some trouble with Sketch and Android Studio, and you have a UI question. What exactly is your question? If you could elaborate on that. And while I'm waiting for that feedback, I'm just going to run a quick commercial break. Also, if you've enjoyed the show so far, please do me a favor and hit the like button down below. Anytime now. Hey, what's up, Zypher? Thanks for stopping by. All right, well, I'm going to give you like a minute, Beulah, and then Folgers plug. Yeah. No, I don't have Folgers in this cup. I have friggin' like the cheapest Walmart generic brand dark roast. Because to be honest, I've been through some times of having a very tight budget, and it's funny, like you kind of start to get used to lower quality stuff. So I actually, as long as it's dark roast, I generally don't really mind if it tastes like boat gas or not. All right, well, I haven't really gotten a response from Beulah, so I'm going to move on. This is just a quick question because I don't actually know the answer 100%, but one of the questions by the crazy ones was that the question was, does Facebook, Google, or Instagram use Java for their Android apps? So the thing about that is like, I can't tell you that 100% because maybe they do use something else, but for example, Google, absolutely, their applications, Android applications will be written in Java, which is like the de facto platform programming language. Although probably for some of them they will use the native development kit, which is C-based and stuff of that nature. Yeah, absolutely. That's a great question. All right, so let's, this is a good thing that I can sort of focus on here. So Zlifer, am I in full cam? There we go. So Zlifer asks, can I give an example of a unit test? And I'm very happy to do that because, as most of the people who've watched me so far know, I'm a huge fan of test-driven development and unit testing. So, can I give an example of a unit test? I'm not going to spend a ton of time on this because I have explained unit tests and test-driven development probably more times than me and my viewers care to listen to, but let's just dive right in. So the code I'll be looking at here is totally open source. You're going to want to check out RecyclerView Demo 2017. I should have the repository in the description box. And the class I'll be looking at is a controller class. And the test I'll be looking at, which is of course in the test package, is controller unit test. So let's just start with a couple of definitions to begin with. What is this controller? So this controller object, which in some implementations might be called a presenter, basically what this controller does is it's a decision maker. It's something which the other parts of the app will feed information to when the controller asks the other parts. So it does thinking and logic and coordinating different layers of the application. Now, naturally, that is something which is going to contain lots of logic gates. Now, in this particular case, I have kept this very, very simple, but what we're trying to do with our unit tests, or here's a general rule for unit testing. A question I had before was like, what should I unit test? What should I focus on? Do I need to test everything? Blah, blah, blah. In general, for unit tests, you'll want to test classes which have lots of different sort of behavior based on logic, lots of logic. So in most cases, if you have good separation of concerns and you're following an architecture like model, view, controller, depending on how you do it, there's different ways to do it, but the view shouldn't need to be tested really with unit tests. You can hit it with some espresso testing. But the controller, which is the logic center, should absolutely be tested. What are unit tests and why should we apply those tests? Well, again, there's some different ways to apply unit tests, but my general suggestion is on the Android platform, you're going to want to set up JUnit and Makoto. So that's the main thing. So with JUnit and Makoto, what you can do now is, for example, with Makoto, you can annotate different parts of your architecture, or different classes, I'll just say. I'm so sorry. I'm really bad at that. All right, let's get this. Sorry about that. So let's just continue on with unit testing. That was just a fail. So we're looking at this class here, controller unit testing, and this is the logic class I was talking about before. Go ahead and check out the code in the repository, and it'll be a lot easier for you to follow along. So I use Makoto and JUnit. You can add those into your build Gradle. And what Makoto allows us to do is we have this mock object, or annotation. So I can annotate different parts of my application as like test doubles. So in this case, I have this class called controller unit test. Now you don't necessarily need to name it that. I was kind of playing it up a bit, but you would call it like controller test or something like that. And basically what you do here is we set up, you'll notice when I go to this controller object, it's talking to two other layers of the application. And this is really key, and I do apologize I can't zoom in over here. But it's talking to a view which exists in this view layer, and it's talking to this data source which exists in the data layer. So that is kind of a fundamental thing here, is that why are we talking to this controller? Well, it has references to other things, and it's going to be receiving input to other layers, and that's why it's especially important to test. So for writing the actual unit tests, my process is pretty straightforward. So as a general purpose, here's my general purpose step-by-step process to test your classes. So when you're writing a unit test, you set up and mock your test doubles. So we're testing our controller object, and we're testing it against fake versions of the classes it will need to talk to when it actually runs. So this is the real controller class being tested by a fake view and a fake data source. Why do we do fakes? Because then we can simulate behavior, input, and output and test what our application does. So then what that ends up looking like is for each unit test, and I label these things very deliberately, so on get list data successful. So when we say to the data source, get me a list of data, and it happens successfully. Whoop, there we go. And yep, and then we can have other tests like on list item clicked. Yeah, stupid phone, shut up. And so what we basically do is we'll create whatever kind of data we need to, we'll create our test data, and we'll set up our mock objects. So what we're testing here is specific sort of part of our implementation, a specific sort of behavioral thing that we want to simulate. And what we want to simulate is when our data source returns a list of data. So I create a fake test data to return, and then with Makoto I say makoto.when, and then I say data source, which is of course our fake data layer. I say when the controller says, hey, get a list of data, then that fake object will return my fake list of data. Now, a key takeaway here is that the controller doesn't know or care that it's fake. It shouldn't. Simply put. Then, of course, we call the method. So we set up, we pre-configure the data we want to return in this particular test case. Then we call the actual method on the real object we are testing. We say, call this method, just like it would when we're actually running the application. And lastly, the final step is we verify what happens. So, and this is how we decide, this is how we design our controller class before we even write it. So we say makoto.verifyView, set adapter and view. So what I'm saying here is I want to know this test will pass if and only if when I call this method, controller.getList from data source, the controller calls this method, setAdapter and view, on our fake view. And if I run that test, it should pass. I'm not going to just because it CPU hog. So that's basically the general gist. Now, what I'm going to suggest to you, so for anyone who wants a very detailed explanation where I write the friggin' unit tests in front of you and give a much better explanation, you are going to want to watch my RecyclerView 2017, sorry, it's called Let's Build a RecyclerView App Part 2. And in that, I walk you through writing all of this stuff step by step. So go and check that out if you would like. And that is my answer for unit testing. Okay, so this is a good addendum. So I'm getting a lot of questions about Dagger 2. And what they're really centering around is that so we've got Iman and Mithu are kind of asking, like, so they don't understand, they're having difficulty wrapping their heads around Dagger 2, which is very common. It's a friggin' complicated and obscure thing, and it's generally explained very poorly. Yeah, that's... The thing is, like, I need to prepare a long lesson for you, which I will do eventually, to really explain the deep fundamentals of Dagger 2. And the thing about it is that even if I were to show you a really simple implementation of Dagger 2, that will not actually help you that much when it comes to making Dagger 2 work in the context of a big application. The thing about Dagger 2 is that it's a little complicated to understand just in the very basic sense, but it's actually like dependency injection itself is super simple. That is one thing that gets over-explained so much. Oh, I hear sirens. I guess my ride's here. Anyways, but the thing is, like, let me briefly talk about Dagger 2, but unfortunately, guys, I'm not going to be able to dive into that today because it really warrants very careful explanation. So this once again, I did it. So this application I've got pulled up here is called POS Trainer. Again, it's open source down in the description box. Go check out the GitHub. And if you open that up, you're going to find a package structure, and we've got a couple of different things. So when you're setting up Dagger, what you're generally going to do is you're going to need to extend your application class, which is something you don't often have to do in Android, but in Dagger 2 you do. And then you create all of these technical words. So you create these modules and you create these components, and these modules and components do different things. And we've got, like, it's so complicated, but just in a general nutshell, what you kind of want to do, the big idea here, in the general sense, and this is really all I can give you, the big idea with Dagger 2 is that you're trying to decouple the code which creates objects into its own kind of layer or its own kind of part of your app that kind of manages it. Now, why is that important? Well, again, at the more advanced level, what that means, if we're setting up Dagger 2 properly, which is really friggin' difficult, then we can do things like, let's say in alarm, here's a quick example. So in alarm receiver, I have this class which, let's see here. In alarm receiver in POS Trainer, I have a class which uses system services. It's kind of obscure because I'm using clean architecture, but ignoring this clean architecture stuff, just kind of pretending it doesn't exist and cutting it out, this presenter will have to talk to this thing called alarm service. And what is alarm service? It's a big service class which manages alarms, media players, vibrators, all these different things. Now, in a typical Android application, I would be within my activity asking the activity for this stuff. And then all of this stuff would live in the activity. And that's a problem because activities are fragile little flowers that get destroyed the moment the screen tilts. So what Dagger 2 has allowed me to do is it's allowed me to create this alarm service class and decouple. So pull the creation of these objects I need out of where they are inconvenient into their own separate classes. And so that way I've got this alarm service class. I slap this inject annotation on, and when the application creates this thing, it's going to say, hey, I need all of these different dependencies. It's going to jump into my application class and do whatever it does. It's going to go to the component, and what it's going to do is it's going to say, okay, I need to get all these things, and then it's going to check out this module. Then it's going to go to the module, and this module is where we've pulled the code to create this stuff out of. So instead of saying instead of saying like get context.get system service in an activity, we're doing all that in an application module, and the extra benefit of that is we can make them singletons, which is a big problem. So the thing about this is that, like, I've just babbled and babbled and babbled, and there's so much to talk about with Dagger 2, and this is why I can't really explain it simply. However, I will be doing tutorials on Dagger 2 eventually. I'm still not happy with my own implementation, but my implementation works, it's just not optimal. So that's kind of my opinion on Dagger 2. So what I'll do is I'll do one more technical question, and then we'll get to the procrastination question, because that's very fascinating. So this is an interesting, this is a quick question I can fire off here. So all right, so all masks. How do we reload an activity without, I'm kind of paraphrasing a bit, but destroying the activity's UI? All right, so how do we reload an activity without destroying the activity's UI? So there are smart ways to do this, and there are hacky ways to do this. So I will explain one way you can do this and what I would suggest as a general approach, with the understanding that different programmers handle this situation differently. So I'll give you my quick input. But so the fundamental thing, like what we're saying is, let me just pull up an application. Okay, let me just rename that alarm. Okay, so in my hand is Pos Trainer, which is actually the application that I was talking about with Dagger 2. And I know that's not super visible, but it just shows a list of reminders. And you notice my hands shake like crazy because I was born with hand tremors. And so how do we like set up a scenario where the user interface seamlessly kind of flows? So the way that I like to deal with that scenario is I like to decouple my user interface into fragments. And what that ends up looking like is, again, if we pull up Pos Trainer, and this is a very advanced kind of architecture, so this might be a little bit confusing for beginners, but basically what I do is I treat my activities, which, okay, so here's the thing. There's one hacky way to deal with orientation changes, and that is to go into your manifest and for a given activity, just say, you set this thing, where is it? I probably even have it set on, yeah. So for example, in an ideal scenario, your application would be decoupled properly, and well, I'll explain how to do it later, but so a quick way, and this is not something I recommend for all use cases, is to restrict the screen orientation of a given activity. Now I'm going to explain why I don't like to do that unless I have to. So in this particular case, for the alarm detail activity, which is this activity here, you'll notice it does not change on orientation. Now, after explaining why I don't want to do that, why I hate doing that, because it's a hacky way to do things, I had to. And the reason why is that Time Picker is basically like the most annoying and inconsistent compound view I've ever worked with, because it looks different on API 21 and 23 and all kinds of stuff. So in this particular case, or if you were writing a video game which is meant to be used in a certain orientation, you can restrict the screen orientation. You're not generally going to want to do that. How you'll generally want to handle this situation, how I like to, is, for example, let's open up the list view, because that's one that actually changes. So alarm list activity and alarm list fragment. And basically, what I want you to, the way I structure my applications is this alarm list activity is just a container. It contains the view, the user interface. It contains the user interface, but it isn't the user interface. It contains that user interface within a fragment. And this, so essentially what happens is I offload all of the UI into this fragment, so it has all my views and all that stuff. And then within the fragment, I call setRetaininstance to true. So what this will do is that when your application orientation changes, the activity itself will get destroyed. This thing gets destroyed. The only way this thing does not get destroyed on orientation changes is there's some, I forget what it is, but there's some method which is basically the same as fragment setRetaininstance, except it's the activity version of that. I wouldn't suggest you use that. So once you have this thing set, basically what that tells my application is, okay, when the activity changes, don't destroy the fragment, but do basically the flow that it goes through is when the activity gets destroyed, the fragment detaches. So it detaches from the view. Once the activity gets created again, recreated, it attaches back onto a new activity instance, but it's the same instance of the fragment. Now, one last important thing to note. What setRetaininstance does is it will retain the state of your fragment when the orientation changes. So if I have like a list, an array list of alarms, that application state will be maintained. However, the view, the UI, still gets created again. And what I mean by that is that onCreate will not get called again. OnCreateView will get called again. This view will still be recreated. So that is my general suggestion for handling orientation changes. The proper way is to bring your user interface into a separate class from the activity. So basically what we're doing fundamentally here is we're saying, okay, let's take the stuff that I don't want to be recreated and pull it out of the thing which necessarily gets destroyed a whole bunch. Like, it's kind of simple logic here. And then manage it that way through setRetaininstance. Now, again, there's different ways to handle it, and you'll hear a lot of different opinions. That's just my personal approach. All right, so I'm just going to take a moment's break here and run one more commercial break. So a quick question from the crazy ones. He or she, presumably he, but just statistically speaking, but this person is asking, can we create an app like WhatsApp or a chat app with Java? Absolutely. You can really pretty much build any kind of application in Java. The question is, do you want to? Now, you're going to hear a lot of opinions about that, but to give the example I like to use is that in one of the fragmented podcasts, I was listening to an interview with Jake Wharton, who is a very good programmer, and he works for this company called Square. Excuse me. And Square is I believe you might call it an e-commerce or a money management company. It does a whole bunch of stuff, but it is an enormous money management company, which is probably way more, well, it's at the very least as complicated and as difficult security-wise as building something like a social media chat application. And I do remember Jake mentioning that a lot of their application, their web app, is written in Java, their server side. Now, it's not only written in Java, and the thing about it is, like, what are the drawbacks between writing it mostly in Java or writing it mostly in one of the new web frameworks? Don't really listen to people who haven't done both or don't know about both. In my case, what I will tell you is that it's absolutely possible to write that stuff in Java. whether it's better to do it in more specialized languages, because Java is very generalized. It's like the Swiss Army knife. I couldn't tell you. All right, so oh, Jake Gordon's at Google now for the Kotlin team. Uh-oh. Well, they've always worked together. Okay, so let's get to the question I was going to answer earlier, and this will be the last question for today. And I'm going to try and do a good job with this. This is the kind of topic that I would normally want a bunch of time to prepare for. But I've had several people ask me about this today, and I will do my best to answer this question. How to deal with procrastination. So the first thing I need to mention is that so the thing about procrastination and motivation and discipline and all these different things, they are somewhat arbitrarily defined. They're subjective is a better way of talking about it. So one of the to ground this with some practical advice. So when I started Android development back in 2014, the biggest issue I had to deal with is that I was a very lazy and ADD and kind of chronically exhausted person. And at the time when I started, I was working full-time with split days off. And really the only time I had to learn Android development on top of all that was to wake up really early in the morning and study before I went to work. And over the span of 3 years, I've gotten better at doing that. I've gotten better at doing what I need to do on the days with which it is required of me. So the first thing I must mention about procrastination is that you must have a clearly defined goalpost. So that's the first thing. You need a clearly defined goal. So for example, I want to build an alpha version of my first Android app in 1 month. So let's just assume you have a goal. If you don't have a goal or a specific rubric for success, you need to go and find that. You need to go do that. Because otherwise your brain doesn't really know what to lock onto. So you need a specific criteria for success. So that's number one. Oops. Number two, you need an action plan. So for me, that was for every day I will wake up early, wake up a few hours earlier than normal so that I can learn programming. So we've got our action plan. Get up a couple of days earlier so that I can learn programming, so that I can work on this application. All right, so you've got your action plan. So that's the second step. So we've got our goal. You've got the goal. And then you have steps. If the goal is like a destination that you're walking towards, we've got the destination. Now we're saying, okay, what steps every day can I take? And generally that'll be just study a couple hours. Like if your goal is to lose weight, every day do a walk or a run, you know, that kind of stuff. So you've got your action plan. So most people can make it here. This is not hard to figure out. We're all like fairly intelligent human beings. We all understand, all right, so you need to have a goal before you can improve yourself or achieve something. And of course, you need to have a vague idea of what steps you need to take. This is not a very important thing for me to talk about. What I will talk about, and this is one of the most fundamental concerns of my own personal development, which is on the days when on a given day when it is required of me, and I'll briefly touch on what that means, when it is required of me, how do I make sure that I sit down and get a good amount of work done, whether I want to or not? So one of the, I've talked about this before passingly in posts, but so here is the bane of my existence. The bane of my existence are the days when I wake up with every intention to get a ton of work done. And we all do this, and I'll continue to do this. It happens less and less frequently, and I have tools and resources to deal with this. But what happens on those days when you don't feel like it? Because you're going to get days where you wake up and you're just intrinsically motivated and you get to work and things are great. How do you deal with procrastination? How do you increase the number of days where you are learning and working effectively? So really what it comes down to, in my personal experience, the most important thing you need to realize, and this is so important, is that what I used to do is on a given day when I was feeling bad, on a given day when I wake up and say the previous day I'm like, all right, I'm going to get a shit ton of work done tomorrow. And then I wake up the next day and I'm like ADD, and then I sit down at my computer. Maybe I check my phone and I look, oh, I got a question on Facebook. Then I go to that. Then I try and bring myself back. Oh, I got a program. Crap. Procrastinating. And then I look up, okay, today I'm studying the Liskov substitution principle. And then as I'm looking that up, I see an interesting article or an interesting thumbnail. And then I jump to that. And then all of a sudden like 2 hours go by and I've gotten basically fuck all done and nothing done, pardon my language. And that's the situation I'm sitting in. And then I'm sitting there and I'm thinking, you idiot, like you had all the spare time that you could have used productively, and instead of doing that, you pissed your time away on nonsense. I don't think that is the right perspective. The perspective I take now is when I wake up on a given day where I have that feeling, I do two things. I do many things, but most importantly, two things. Number one, I say to myself, what did I do yesterday to make me feel like this? Because the problem is not that I'm just lacking this magical enthusiasm and then I make this big story about myself like, well, I guess you just don't care about getting your work done. That's bullshit. That's absolute bullshit. In general, the days when I wake up and I feel like crap, I can point to things I did yesterday and the day before which led to me being not very well in the head, in the sense that for me, and you will need to examine your own life and your own, and this is where it gets general, your own dietary issues. Do you work out? Do you drink a ton of sugar? Do you, when you start at the beginning of the day, do you go right into your first primary task, or do you check Facebook and get distraction momentum going? Because once you check the Facebook thing, your brain's like, oh, Facebook, Facebook, Facebook. When it should be like, oh, Liskov substitution principle. So what I'm trying to say is stop beating yourself up in the sense of making a story like, oh, I guess I'm lazy, I'm useless, I'm this, I'm that. That's bullshit. That is really just bullshit. What you say is, number one, I am going to do better. What did I do yesterday that screwed me up? For me, over the 3 years, I figured out eating a ton of carbs the day before will make me retarded. Pardon my language. I don't find that a very offensive term, but some people do. It will make me ADD and I'll have trouble thinking. The next thing I do, and this is what I will end on to end procrastination. On rare occasion when you wake up on days like that, sometimes you'll be able to sort of reorient yourself and push through. And that's always what you want to do, is you always want to follow through on action item number 1. Let's study the most important thing. If that most important thing is something that's very complicated and your brain is just tired or it's not in the capacity to work with that, what you need to do is you need to now say, okay, looking at this objectively, I've tried repeatedly to focus on this one thing, and I do not today have the focus to get it done. I seem to be procrastinating on this for whatever reason, except that I'm just a bad person. That's never a good reason. I am not able to get this work done. So then you say, okay, what is something that is easier, that still needs to get done, and only takes maybe an hour? So what I will do is, let's say I sit down to work on my room sample and my brain's just elsewhere. I will say, after a little while of trying, okay, I can't do this thing today. What are some easier tasks for me to do? So for me, that's writing. Writing is super easy for me. So then I'll say, all right, before you quit and rest, before you rest up, because obviously you are tired, I want one thing done. One fairly straightforward, simple task that takes maybe an hour, half hour, something like that. And before you give up and rest for the day, that thing gets done. And that is not optional. Once that thing is done, then you say to yourself, okay, do I feel like continuing? Or do I need to rest for today? If you feel like continuing, you can go ahead. If you are still really tired and it's still a struggle, then you say to yourself, my only goal for the rest of today, and this is the end of this diatribe, my only goal for today is to make sure that tomorrow I am adequately rested, I've eaten well, and I have a written plan, and I am ready to do better tomorrow. And that's basically it. So hopefully that was useful to some people. I know I rambled for a very long time. And to be honest, like, I would rather create a very long and dedicated explanation of this whole thing. But if that was useful to some people, great. If not, great too. And thank you so much for watching. It's been a fun episode. And I will see you all later. Peace out. Work hard. Work your ass off. Like C.T. Fletcher says, what is it? ISYMFS. Look up what that means. C.T. Fletcher.